Alright, welcome to an elementary introduction to the Wolfram language using the Clojure Wolframite integration. Because I have a license, so yeah, I'm having some fun with Wolfram and Clojure. I do this and then I go to Clay. This is the display lists. Notebook. Okay, so if I say here, I change something. Okay, it takes a little bit. I have now put this function as a hook in Cider. So that basically I have this working on save. I achieved this by adding a hook on the buffer that I want to have this set up, and then you use the third argument to add hook. That it says that it's buffer local. It's important to know. So you say here t, and then there's a hook called after save hook. So when you save, then this list of functions is called, and in this function I use cider and REPL sync request. So depends on cider REPL. But yeah, this is basically the basic setup for a Clay. Of course, it's ad hoc right now in my running Emacs. But that's the stuff that you can do if you have this program. Can later think about how to develop, how to ship it to somebody else or something like that. But yeah, this would be my Clay setup here in a sort of a user file, and then I have a notebook file. Okay, and yeah, so here I was using the Wolfram hiccup namespace to produce hiccup forms from the Wolframite code. So yeah, it's works all good. Kind of nice. It makes exactly the kinds of pie charts that the Wolfram also displays here. There are some differences. I can't render a list. Or can I render a list? Wait, I'm gonna try again. Because there were some things I needed to figure out that have to do with the evaluation model of lists and vectors. You need to be a bit careful. If I run into it, I will talk about it. But yeah, in general, I just go quickly through it because I actually want to go through this book myself here right now. So, okay, so let's try to render a list of things. Okay, so I'm putting this here at the bottom. Oh, this is a number line plot. Okay, so let's say that I want to render a list of 2 number line plots. Then I use the Wolfram list of 2 number line plots. What will that do? No, this does not work. Yeah. This actually makes this is funny. This makes a GIF. Yeah, it's a bit crazy. I can say here 1, 1, 2. No, I get some dot that jumps there. There. So this by default makes a list, makes a GIF out of the input that has to do with this API here. The Wolframite hiccup API is calling the Wolfram API evaluate to image. I think that is the problem. Not the problem, but yeah, it's insufficient. Basically, it's missing the version where it would render an actual list. It's fine. It doesn't affect me here at the moment. Oh wait, maybe I need to say list. No, This is the same, yeah. This is the same. Yeah. Not sure. I can make a column though. So I can make a column instead. If I make a list as argument here, then I get a column of 2 number things. So instead of next to each other, below each other, whatever. Yeah. But this works quite well. Okay, so these are the plots of lists. Okay, next, operations on lists. Okay, like this. Then I go to the user. I'm gonna just change this to this other file. I only need this part. Okay, so I'll just reevaluate this. Okay, and then I'm gonna say set up this on save. Okay, empty sheet. You can also write a markdown here. So I could make a title here in markdown. Like that. Okay. There are thousands of functions in Wolfram language that work on lists. This is probably not an exaggeration, I guess. Okay, you can do arithmetic with lists. Alright, okay, so I can write Wolfram code. You can always write the string Wolfram code and send it to evaluation. That makes an element-wise addition, I think it's called, or something. And then let me write this in terms of Wolframite, I guess, plus as a function. Then you pass in a list, can be a Clojure list, will be transferred to a Wolfram list. Then a Scala 10. Clojure numbers are Wolfram numbers. Yeah, this is the same. This is equivalent. So yeah, I use the string thing is useful. I mean, because sometimes you have some snippet of Wolfram, maybe you want it. Otherwise, this thing is of course more code, more of a code concept. Okay, so now 1, 2, say Wolfram multiply. How's this operator called? Times? Okay. 1, 2, 3, and then Wolfram 1, 2, 6. Okay. This is a vector product, I guess it's called. Okay, compute the first 10 squares. What? So yeah, this is a list, and then power list power something that also works. Okay, so instead of a fixed list, you can also produce a list using the range function. So range and then power this times 2. Okay, these are the first 10 squares. Plot the first 20 squares. So I'm gonna say view and then here list plot. I already know it from the last exercises. And then we set the first 20. Okay, and then I go to my notebook. Okay, cool. That works good. It has limitations, but yeah. some stuff works. So far, I'm going through this kind of sorts a list into order. Okay, sort, sure. 6, then sort. Execute this. It sorts the list. Alright. Length finds how long a list is. Okay, length of something. Alright, then total gives the total from adding up a list. Oh, okay. Total 15. Total range. Yeah. Typing this in, so I know how to type code. That's the basics. Count counts the number of times something appears in a list. Frequency. This is frequencies in Clojure. A, B, A, C, B, A. Count A. Achso, takes a single thing. Okay. Like this. Achso, this needs to be quoted. Oh, wait. This one needs to be quoted too, yeah. True. Okay, this is of course the same as in Clojure. Yeah, saying frequencies and then get A would have been the same. It's often useful to be able to get individual elements of a list. First gives the first element, last gives the last element, part gives the element at a particular position. Okay, so first 7, 6, 5. Last, and then part with an index. 2 is one based index. I think Wolfram is 1 based. Range is also, for example, starting at 1. Okay, picking the first element in a list you sorted is the same as finding the minimum element. Achso, sort, yeah, sure. This is like finding the minimum. 6, 7, 1, 2, 4, 5. And then say first. And then there's also, of course, a function called min. Would have been the same. If you have a number like 5, 6, 7, 1, you can make a list out of its digits using integer digits. Oh, funny. Okay, this is a function that is not in the core library of Clojure. This is the first one, I think, because of course we have a min function. And we also have first, and instead of part we say nth. And it's 0 based, so I would need to go one different. And these are the same. Oh, force. So we need to min is a variadic function. Different in that sense. Then integer digits. Okay, this is integer digits. Right. List like this. So it's a single list. It's a single number. Okay. It's kind of funny operational. Yeah. If I would be would be writing this function, I would take the funny shortcut and then I'm not sure if the semantic would be actually correct. Oh, oops. Sieg. Kind of, right? Kind of. How does integer digits work for a floating point? Ah, this is an error. Okay. Yeah, not float, not either way. The last digit, last integer digits. And then last. Okay, take lets you take a specified number of elements from the beginning of a list. This actually doesn't exist the same in the same way in Clojure. 401, 600, 2, 3, 3, 2, 4, 1, 2. And then say 3 things. Like that. Can check if the notebook. Ah, the notebook actually has an error. Okay, looks like this. Okay, and drop, same function. Actually, the same function. Actually, the same name. Okay, drop 3. Then I get the rest of the list like this. Okay. Vocabulary, arithmetical list, sorted list, length. Total is the same thing as I would write total as, for example, reduce plus. This is total, then count, first, last. These are obvious. Part is the same thing as env. Take is the same thing as take in Clojure. So the first whatever items drops the first whatever items. Integer digits, kind of funny. I never needed integer digits. Returns a list of the digits. I guess this also takes as a second argument the base or something. Yeah, radix. Yeah. B is the base here. So that is 10 by default, right? Yeah, and if this would be binary, okay, this is the that actually is kind of cute, right? Give me a list of the binary representation of the digits. I think that's kind of funny. What happens if I say 1? Does this make sense? Ah, this is an L. Okay. Can you use all kinds of bases? Can you use 3 as base? Ah, yeah, you can. Okay. What happens if I use this number as base? That means that 1 means the number, right? So that should be 1. Ah. 0, 1. Funny. And what if I say and 0 doesn't work, right? Yeah, of course not. I guess. Yeah. Wouldn't make sense, I guess. Because how do you say you have 0 amount of digits to talk about what number your number is? If you have 1 digit, you can also not express anything because oh wait, 1? No, 1 also is an error. Yeah, okay. It's only with 2 that you can start talk about a digit representation. But I was thinking with 1 you could still make a list that is just has exactly this length. But that would be a different kind of encoding, I suppose. Not a digit encoding or whatever. Okay, so 2. Yeah. And what if I say base? Does this make sense? Base this, then how does it say now? So yeah. So yeah. And if this is my base, then now you have 2 0, right? Yeah, because you have 2 times this thing as base. Yeah, and if I would say here plus 10, then it would be 2 10. So not the base. Sorry. If I would say plus 10, then I would have 2 10. Yeah. Okay. Make a list of the first 10 squares in reverse order. Okay, this is easy. So we make a list of the first 10 items, then we say power 2, these are the first 10 squares, and then we say reverse. Looks like that. Find the total of the first 10 squares. Okay, so do the same thing, and now I say total. Make a plot of the first 10 squares, starting at 1. Okay, so I'm gonna say view and then list plot again. Oh, there's an error. Else set in this context. What? Oh. What? Another error. This is an error. Yeah, okay. I have here one of these things was an error. Okay. Yeah, we already did this. I suppose it looks almost the same as this. So here it was 20. So it's the same thing. Oops. Deleted this file. Is that what I wanted? Okay. I deleted my browser, I mean. Use sort, join, and range to create this. Okay, I see what they are thinking. They're thinking that I do range 4. Yeah, and then do this 2 times and join, which is the same thing as concat. And then sort afterwards. And then you get this out of it. Use plus to make a list of numbers from 10 to 20 inclusive. Use range and plus. Okay, so you say 10, and then you say plus 10, so we inclusive. I need to say range. I need to say plus 9, I think. Okay, and then 11. That was a bit strange, but yeah. Yeah, with plus start further on top and then go 10 things far. Or maybe it would be nicer to say here 1 and then this work. It starts at 12 now. So it would be -1. Yeah, like that. So inclusive. Okay, whatever. Alright. Make a combined list of the first 5 squares and cubes. Numbers raised to the power of 3. Sorted into order. Okay, 5, range 5. Yeah, then I say power 2, and then I do this a second time, and then we say join, yeah, and then we say sort, and it's this. Find the number of digits in this. Okay, so I say power to the power of 32 is this number. Well, yeah, after evaluation, and then digits, integer digits. Oh, find the number of digits. Also, and then count. Yeah, makes sense. Interesting. It says was it count or was it called length? Count takes an argument. Count list pattern. Everything that matches the pattern. Okay, so I would need to say the pattern that means everything. Oh, that's not correct. No. Yeah, it's funny. I can't solve this at the moment. Mathematika, pattern, everything or something. Blank. Blank? See if this will work. 0. No, it just says 0. Okay. Not great. Ah, no, 10. Wait, 10? So it's probably correct. Okay, so alternatively I could have of course used Clojure. Give me this list and then count the list as 10. Yeah. Okay. And of course it doesn't matter if I say X here or foo, right? But I need to say a symbol for this pattern to work. Yeah, I guess there's a syntax for patterns. But yeah, I mean this is fine. This is fine. Yeah, that's totally fine. I mean, there's in Wolfram. So I guess I can quickly try to write the Wolfram code. Integer digits. Say a list. I'm just gonna make a list. Okay. So now I call the Wolfram code. Okay. Integer digits. Oops. 1, 2, 3, 4. Okay. And then count. And now what? Count the 1. That's 1. Count the 2. It's 1. Count the underscore x. That's 0. Okay. Count the x underscore 4. Okay. So Wolfram patterns are kind of like, there's basically reader syntax for Wolfram patterns, I suppose. It just reads it as a pattern. And a symbol with an underscore is the blank pattern, so it matches anything. Okay, find the first 10 digits of to the power of 100. Okay, so you say to the power of 100, and you say integer digits, and then you say take, and the second argument, like this. Find the largest digit that appears in this number. So max, even though they didn't talk about max, but max. If min exists, then max exists. Find how many zeros appear in the digit of this. Okay. So it's the same thing. Like this, and now I say 0. 28. Use part sort and integer digits to find the second smallest digit in this number. Okay, so this number and then the second smallest. Actually no, I need to. Every number comes up once. Okay. So we were lucky. We were lucky. Because if the same number appears multiple times, then this would not have worked. But because it's the special case, that works like that. Yeah, 1. The answer is 1, right? Yeah. Make a line plot of the sequence of digits that appear in this number. Okay. And then here I say line plot, a list line plot. And then view it. Oh. Something is wrong. So I needed integer digits. So like this. Oh yeah, okay, funny. This is a number that has 8 times. One sec, what does it mean? It means that the 0 appears 2, 3, no. So it means that at the 0 position there's the number 3. Yeah. And then at the 1 position, or the 1 position is the number 3, and the second position is the number 4, and so forth. That's what it means. It's 3, 4, and so forth. 3, 4, 0. Yeah. Okay, there was a line plot. Oh wait, a line plot. Yeah, a line plot. Yeah. Okay. Use take and drop to get the sequence 11 through 20 from range 100. What? 11 from range 100. What? So I'm supposed to say range 100, and now I'm supposed to say okay, drop 10. Yeah, that starts at 11, and then take take 9. No, take 10. Okay. Make a list of the first 10 multiples of 3. The first 10 multiples of 3, yeah, like this. Say multiply times, and then times 3, yeah. Like this. 3, 6, 9, 12. Make a list of the first 10 squares using only range and times. Okay. Also, like this. This is the number times itself. Find the last digit of 2 to the power of this number. Alright. So you say last. And then here you type the number that they ask for. 2 to the power of 37, and then evaluate it. Find the second to last digit of this number. So last. Yeah, you can count. Yeah, without using things that I don't know yet about. Okay, and then -1. And then part this. What doesn't work? 10. -1. 10 minus 1 doesn't evaluate to anything. Why does it work like that? Ach, minus is the negation. Okay. So if you have the wrong number of arguments to a function, you also return the expression instead of anything. Yeah. Kind of interesting. So there's probably subtract instead. Yeah. Okay. So subtract. 9. Yeah, that's correct. Yeah. This is the number, and then the second to last is the 9. Okay, and now find the sum of 3 to the power of 1 to 6, and then, yeah, like this, total. And evaluate that. Make a pie chart of the sequence of digits that appear in 2 to the power of 32. To the power of 32, then integer digits, and then yeah, pie chart, yeah, and then make hiccup, save the file, go to the notebook. Looks like this. Make a list of pie charts for the sequence of digits in. Make a list of pie charts. So, okay. I'm gonna make a column of pie charts to the power of 20, 40, and 60. And then make a list here. Save this, go to the notebook. It doesn't work. Also, view. Make this hiccup. Okay. Can one add lists of different lengths? No. Can't do that. Can there be a list with nothing in it? Yes, the empty list. Null list. Or empty list. Integer digit gives the digits in base 10. Gives the digits in base 2, yeah, if you pass a 2. You can use any base you want. Number from its list of digits. From digits. Funny. Okay, that's cute. From digits. Okay. Rest gives all the elements after the first one. Most gives all the elements other than the last one. I would have needed most earlier. Okay. See you later.